All right, so what's my first part? So when I say I want to go faster, that kind of depends on y'all. If y'all don't respond, it makes things go slower. So I want to go faster, so I want y'all to respond. So what's my first thing in state? So I got let mu with probably my first subscript. And this is going to be what? There's one thing that this problem did not give that my last class printed out. What does it not specify? Your units. Now, I'm not sure what those would be if they weren't pounds, but it didn't specify that, and it probably should have. All right, so then what? The true what? I'm going to point this out tomorrow, but true difference in means that, I'll point it out when I do the other side. Okay. What do I need from there? So you state your direction. There's no reason that I chose this one first other than the fact that it was written first. And then what? So this one, the wording was not bad at all. Straight into plan was my first part. And this is a 2 sample for what's my first condition? And this one was stated random what? Did it say selection or sample? Random sample for both pro football players Remember, you have to be explicit to what the both are. And then I still need random selection. I'm going to go out of order because I'm going to have to handwrite the normal part. So I'm going to go ahead and skip to independent. I can do it all on the other page where I'm handwriting. Independent, which is 10% condition. So I'm doing capital N, subscript F has to be greater than or equal to N times lowercase n subscript F. My sample size for this one is what? So this is going to be 210. For my next one, it's subscript letter B. And how many are in this one? So the wording of how you choose to write it might vary, but there are at least 210 pro football players. You might add something that you don't really need to add that part because we just say population. And so your independent condition will also be pretty straightforward for that one.
Can you put it was stated independent for that?
Oh, yes, thank you. This is one of those weird ones where up here it actually said the word independent. So checking the way that we did this is absolutely fine and it counts. If someone caught on to that, you are basically answering it the same way as you do here, but with independent instead. I'll do this in a different color. So this would also work. Didn't mean to make that part red. So stated independent for both pro football players and pro basketball players. In a typical problem, if this were the route you could go, it probably wouldn't even tell you that they were independent. It would be something like rolling a die, and we know that rolling a die is independent. If we were doing something like the idea of rolling a die, what could the problem tell me to do when I'm picking them that would mean that they are independent? Replacing. So if it says you're replacing every time, you could talk about that here and talk about it as independent. But 10% condition works, and it always works, and I don't have to talk about it situation to situation where it could be what it couldn't be, and it gets confusing that way. So if you notice it, you can use it. If not, use this, and then you're fine. So either one of those works. But thank you for bringing that up. I forgot to bring that up. All right, so now I've got to go back to normal. So I'm checking N times F, P, nope. What am I checking here?
You added that thing.
Yeah.
Oh, so I need to write what then?
Stated that almost approximately normal.
So we have to basically do this same thing, this method and this method, where you explicitly mention both. So stated that both pro football players' weights and pro basketball players' weights did I say normally or approximately? I wrote it on the board for y'all's class, didn't I? I'll do this. So I still need what? So it basically becomes one of those where you say that it's stated, you're talking about the population distribution, and you explicitly mention both of them, just like we do with random. Questions with that? So don't just say stated random for both. You have to explicitly mention both. All right, so do, what do I need? What is X bar F?
259.62.
What is SF?
12.056.
12.256.
0.056.
I'm listening, I'm just not writing. 0.56. And we already talked about this is what, 21? My X bar B, what was that?
205.79.
My S of B would be
12.9.
just 12.9. And then this was 19. What else do I need?
Pencil.
Which was
95.
anything else? So I can go straight to my generic equation, which is X bar what? Minus X bar B plus minus what goes here? And then square root of
SF squared
SF squared
over NF.
over NF plus SB squared over NB. What do I put here? UF minus UB. What's my lower bound?
45.806.
And what's my upper bound? What?
61.86.
So I didn't give you units there, so we can't really add it in, even though pounds would make sense. And probably the only one that would make sense there. So then we would say our conclude would be that we what? At the true what? And then I have to specify my direction that I've already specified. UF minus mu B. And then what? I'm writing this so that people understand that usually units should be there, but I understand the problem didn't. And what was it? 60?
61.86.
Questions with that problem? Second problem. I might talk through this more than I write it. College financial aid offices. Oh, I do want to talk about A separately first. This is completely not with this chapter at all. But this is a good point to bring it up and why and all that stuff. So, how can you tell just from this that these are skewed to the right? This should be a very easy question. Not just that it's high, but it is high. If I didn't give you the X bar, could you tell me that S of X was high? So compared to the mean. So your standard deviation is really high compared to your mean. So let's actually talk about what that means, like drawn out. So if it were normal, which this is not, this would be your X bar. This would be your X bar minus S. This would be your X bar plus S, right? So let's just look at for males. For males, this would be about 1885. I'm just going shorthand right now. This would be about 500-ish, right? This would be about, what, 31-ish, 31, 32. Well, how much should still be here if this were normal?
2 times the standard deviation.
So about what percent is here? From here to here is about how much? 68. So between here and here is about how much? So this way would be, how much is this? So how much is this? So there should be about 16% here, right? But why does that seem like an issue? Because what can these not go below? So all of a sudden, they're getting capped right there. So if 0 has to start there, and our mean is here, and our standard deviation gets us all the way to here, then it's going to have to look like that to be a real distribution. Does that make sense? Now, your explanation would be wording-wise a little bit. I think the wording of it is the hardest part to write. But this is a giant concept of our class, so I need y'all to be okay with where we come up with that. So, if it is definitely right skewed, then why in the world can I still do everything I did yesterday? So I drew this one, theoretically saying that it was what? Normal. So, if it's definitely not normal, how am I still going to pass the normal condition is what this is asking. Central limit theorem. So central limit theorem is still going to let it apply. Well, what happens to the spread with central limit theorem? As your sample size gets big enough, so as your sample size increases, what happens to your spread? It decreases. So even though we're getting this cutoff thing here, it's going to happen more in here often because of central limit theorem, and that's why it still works. That part I wouldn't ask you to explain though. All right, so now let's talk through it. So we would define mu. What's one of our subscripts? Mu m, and that would be the mean what?
Summer.
Means. Trying to think about if it said it in one word. You kind of had to put words together, didn't you? How large are the summer earnings, summer job, and how much they earned?
Seems like the
Summer earnings of each. Mean summer earnings of each. Yep, there you go. Thank you. So we could do let mu b be the mean summer earnings of males at this university, male students at this university. Let mu f be the mean summer earnings of female students at this university. So usually look for wording like that so you don't have to think like I was up there. Almost every problem, it's going to give it to you somewhere where it writes it really neat. Almost. And then so the other part of our state would say what?
we
Want to estimate the true difference in means mu m minus mu f, and then how does that end?
with 90%.
With 90% confidence. Plan. So okay, I am talking through this instead of writing this. The only way I can do this if y'all are kind of following along. So participate. I'm going quicker. First part of plan is what? Method. How many samples is this? 2. So it is a 2 sample what? T. I didn't talk about this with this one. What did I not write here? Since sigma unknown. Would be the same reason for the second one. For difference in means. What about random? And this one gets a little funny. We'll talk about it more in the next chapter. But stated random sample, you would still need to say of both male and female students from this university. You could technically say this one different because of the way it said it, of students from this university that included both males and females, if you want to be more correct there. What's my next condition? Normal. What am I going to use? Central limit theorem. So NM is 675. NF is 621, both of which are greater than or equal to 30. So by central limit theorem, we can use normal approximation. Independent, what would I end up having as my numbers for independent? My capital NM would end up having to be what?
6,760. No, that was wrong. 6,750.
All right, so we would say there are at least 6,750 what? Male students at this particular university. And then we do the same thing with females, but it would be what number? 6210. There are at least 6,210 female students at this particular university. It gives you, so here's our S of M, no, X bar M, S of X M, NM, same thing with your Fs. The only other thing I would have to write at the top part of do is that we are doing a what? 90% confidence level. Write your generic equation, and we end up getting what is our lower bound. So our units here would be dollars. And so I would have that this is less than or equal to what goes in the middle? Mu M minus mu F. is less than or equal to, and then our upper bound number would give us
74.
and our conclude would just be we are 90% confident that the true difference in means mu m minus mu f falls between $413.62 and $634.64. Would it be reasonable to say that there is not a difference in the summer earnings of males and females? Would it be reasonable to say there is not a difference in the summer earnings of males versus females? Why? 0 does not fall in the confidence interval. So if 0 would mean they were the same, 0 does not fall in that confidence interval. So no, it would not be reasonable to say that they earn the same. We've got a lot of evidence. We're not even anywhere close to 0 at that point. All right, questions with the way I went over it because I know I didn't write everything out. Okay.